Okay, what we're going to do is we're going to create a simple breakout game. This won't be a full game, but it'll give you an idea of a little bit about C Sharp, etc., and how to construct game elements. So we'll start off, and if Solution Explorer is not already open, open it. Go to Game Setup. This is the start point of the game. There's a little bit of logic in here, but nothing to worry about. Okay, so to start the game, what we probably want on screen is a paddle that we can move left and right. So we're going to create one of those. That's going to be a sprite. So we're going to create a sprite variable. Okay, so I'll put the sprite there, and I'm going to say new paddle. Okay, so what we're going to do, that doesn't exist yet. So we're going to get Visual Studio. We're going to do Control Dot, and when the menu comes up, we're going to select Generate Class. Okay, so we're going to create a class for the paddle. Now we don't actually, when this object's created, by using the assignment, we'll store a reference to it so we could use it, but we don't actually need it. What we've done is we've tricked Visual Studio into creating the paddle for us and making it a sprite. You'll see that when we go to the code. Okay, so if we just go to paddle, and you can see this bit where you've got colon, that's the name of the class, but this is what it is. So it's saying it inherits from a sprite. So this is a sprite. Okay, now I'll need various libraries when I set the sprite up. So I'm going to go back to game setup, and I'm going to copy all the import statements, the using statements at the top. And I'm just going to add them to mine. New paddle sprite. Okay, so we've got to start off by creating a constructor. So we say public paddle, and we put in the braces, and you'll see that I've done it inside the class braces. All right, now the basics for creating a sprite are to say gm.engineManager.add sprite this, so that refers to the paddle. So we add that to the engine so it's managed and drawn. We need to set a position, so I'm going to, well, we'll do a frame first. So we're going to set a frame, a graphic for it, otherwise there's nothing to show. So we say frame.define, and I'm going to use what we call a single white pixel. Okay, now single white pixel is quite useful because you can stretch it to any size you want, and we'll do that in a second. So we're now going to set its position, so we want it to be in the center of the screen, and we can say gm.screenSize.center.x to get the center of the screen, and we want the Y position to be about 100 pixels from the bottom, or 80 pixels from the bottom of the screen. So I'm going to say gm.screenSize.bottom .y dot bottom, because that's a y value, minus 80. Okay, now if I run this now, if I just run it, press F5, you'll see I've got a graphic on screen. I just want to show you that that's working. It's just chugging away building. It'll come up with a title screen, and when we press 1, it'll go to the game mode. So that's the title screen. And you can probably see right down at the bottom there is a single dot. So let's make that bigger. Okay, so let's, on the paddle, we want to stretch it. So we can stretch in the X and Y position independently. So I'm going to make this 50 wide. So I'm going to say SX equals 50. So I'm stretching 1 pixel by 50. So that makes it 50 pixels wide. Normally you'll create a graphic that is the size you want, but this is just a quick way of creating something without graphics. And I'm going to make it 25 high. So if I run that again, so that's the scale factor, the SXX, SY. Press 1. Well, it's not very wide. I'm going to make it a bit wider. But you see the effect. I'm going to make it 100 wide, not 1,000, 100. So press 1, there you go, paddle. Now we need it to move. So what we need to do is the game engine doesn't know about what a paddle is. It knows what a sprite is, but doesn't know what a paddle is. So we've got to put our own code in to move it. So when we've finished defining the paddle, what we're going to do is we're going to say create an update callback, and then we're going to say plus equals because you can have multiples of these, and then we need to give it a name, so I'm going to call it controls. Okay, if the picker ever starts trying to suggest things that you don't want, this doesn't exist, we can just press escape and it'll disappear. So we're going to create something called controls. It doesn't exist, so we're going to say control dot, and then we're going to say generate method, and it creates it here. So we're going to do some input codes. So we need, if the person's holding the left cursor down, we want to go left. If the person's holding the right cursor down, we want to go right. So that's going to be an if, and then we're going to say gm.inputManager.key down, and we're going to say keys.left. Now, if you didn't include the libraries at the top, it would have struggled because this is using the input one. You can see that that's white now. So we need that for the key definitions. So if that's true, we want the sprite to move left. So we do that by altering its X position and we subtract a number from it. Now, everything that we do in the game ought to be in pixels per second. And we can do that by taking how fast we want it to move. So if we say 400 pixels per second, and we get per second by multiplying by the event manager's delta. And that gives us the fraction of time per frame that this code is running. So this code is running 100 times a second. So we don't want to move it 400 pixels every time we detect that the key's down, because that would move it 4,000 pixels in 1 second. Okay, so that's not good. In fact, it'd be 40,000 pixels, it'd be really fast. So we multiply it by what fraction of a second we're working with. You'll get used to that notation. You do it in most game engines. Right, let's do another if, and let's say if input manager dot key down, and we'll do the right key. So this is just the right cursor. You can set what it keys. If you want WASD keys, you can use those. So again, I'll put the braces straight in. I'm going to go the other way, right. So I say plus, and I'll keep it the same speed because that would be daft not to. gm.eventmanager.delta. Okay, so that'll let us move it. Let's just check that that works. So I press 1 to start, and you can see we move left and right, but we can go off the screen, so we don't want that to happen either. So we can modify the constructor, this bit. You'll see that a constructor doesn't look like a normal method. It doesn't have a return type. There's nothing in that gap. If you look at a normal method, it's got a return type. This is just a subroutine that does not return anything, so it's just got void in there. Right, so we can set up a limit box. So we can say limit initialize, and a limit box allows us to do things within a certain window. We're going to look at the viewport. So we're going to say limit.viewport action, and then we get asked to pick a limit action, and we want to say stop at. Okay. Now, by default, the limit code runs before any user update code, like our control code. And you'll see the effect of this. So the limit put works, but look, when I'm letting go, I'm popping back because the limit box is cropping our position, and then our update code is moving us 1 frame's worth. So that's how far we're moving in 1 frame. So we don't want that. It works for most sprites, but we want a different action here. For user control sprites, we want a different action. So we're going to say limit dot, we're going to say update before limit equals true. Okay, which will force the control code to run before the limit box is tested. So we want to like move the position of the sprite, and then we want to stop it inside the window. And that should give us the desired effect. So let's run this again. Press 1. And I don't get any jump back, so I'm stopping right at the edge of the screen now. Okay. Right, let's get a ball going round. So that's it for the paddle so far. We want to do collisions, but I'll do that in a second once I've got a ball. Right, so I'm going to create a ball. So I'm going to do the same thing. So I'm back in game setup. I'm going to say sprite s equals new ball. Ball doesn't exist. So let's do control and full stop and say generate class for ball in template.game. I can delete the sprite S now that it's built that for me. And just before I start, I'm going to grab all the using statements above the engine one because it'll put the engine one in. And I'm going to paste them to the top of ball. So we're going to get, again, we're going to create a sprite. So we're going to create the constructor. So just say public ball. We're going to add it to the game engine. So engine manager.add sprite. And we're going to create a frame. So we're going to frame.define. And we're going to use the text library again. And we're just going to pick a circle. So I'm going to have a circle 8x8. Okay. I'm going to set its default position. So I'm going to say x equals gm.screensize.center.x. And the y, we want it above the bat. So if we look quickly at where we put the paddle, we set the paddle to 80 pixels above the bottom. So let's make it gm.screensize.bottom 120 pixels. So it'd just be up a little bit. Okay. And then I'm gonna run a subroutine called launch. Now that was a case where it's the pick has gone and picked for me. I don't want that. So I'm just going to delete that, call it launch, and then I'm going to press escape. So I'm creating a method called launch, which will start the ball running. You'll notice it's made private because it's the class that is calling it, and we don't generally want this accessible from outside. So launch is just going to give it a velocity. So we can set velocity. So velocity dot in the X and Y direction. So let's make it go left. So let's say minus 200. So that'll go left. And velocity dot Y. We want it to go up, so that's going to be negative value. So I'm going to say negative 200. Okay. Right. Okay, let's run that and see what happens. Press 1 to start. And there you go. There's your ball. And it goes off the screen. So we want it to stay in the screen. So we can do a limit box again. So back in the ball constructor. So we say limit initialize. And we say limit viewport action. And we want to restrict it. We want it set to bounce. So it'll bounce within the screen. We want collision detection to work. So what we're going to do is we're going to also make this collision active. And we're going to make this collision primary because we'll make the ball in charge of, because it's going to hit bricks and things. So we'll set it to collision primary. And we want it to actually bounce off things properly, like the bat and everything. So what we'll also do is we'll say that this is a moving sprite, so it's moving under velocity, and that affects the collision system. Okay, for the paddle, for it to hit the paddle, we have to say that's collision active. So let's go back to the constructor and say collision. I can't spell collision. No. Collision. Oh, let me scroll up, find it. Collision active equals true. Now we don't want to set this to moving because if we do that, it'll start bouncing with momentum when it gets hit by the ball. So let's see what the effect of this is. So hopefully it'll bounce off the edge of the screen. There you go. And now it should bounce off my bat. Oh, there's a bit of an alignment issue there. Ah. Interesting. There's a bit of a bug. It doesn't matter for what I'm doing. I think I probably know what the bug is. I don't know. Let's have that one. Yep, okay. I'll have a think about what might be causing that. Oh, I know exactly what's causing that. This is a common problem because I always forget, even though I wrote it. By default, all sprites are defined as circles. So the collision detection is actually not treating the paddle as a rectangle, it's treated as a circle, which actually gave us quite an interesting bit of collision there because it was like bouncing at an angle off the thing and you can see the angles change. But we don't really want that. We want it to be rectangular. So when we set the paddle up, we need to, oh, just wait for it to stop running. Yep, okay, whatever happened there, some bug happened. Right, so it's finally stopped. So what we want is we want to set the shape. So we can say shape equals, so I'm in the paddles constructor and shape dot rectangle. Right, now we might get it. I always forget that. I don't know why. I always forget. It's stupid of me. Right, so this time when it comes back, it'll treat the paddle as a rectangle, hopefully. So it bounce properly. Okay. Now, what you tend to do on these games, you give after spin, or if you hit nearer the edge, it bounces back at a different angle. But we're not going to worry about that. That's something that you could implement later. Okay, so we've got a paddle and a bat. What we also need are some bricks to destroy. So we could create lots and lots and lots of bricks here in game setup, but really we should have a level generator. Okay, so we're just going to create another object, so level, but we're going to tell it what level we want to load. So we could set this up. Okay, so I'm saying level 1 doesn't exist, so I'm going to get that created. So control, full stop, generate class, so that creates the level. Okay, now it doesn't know what the parameter was, so it's just giving it a guessed name. I'm just going to say play level. So I'm going to rename that. Press Control Dot and it'll rename everything. V, that's a bit naff, so I'm going to call it current level. So I'll change the field name to current level. Then do Control Dot and it does the fixes for me. So that's the level I want to play. Okay, so now what I can do is just generate that level. We're not using that level number at the minute, but we could do in the future. Okay, so we're going to say generate level and we'll say current level. So generate that. Oh, I'm being a bit of a div really. I'm going to do that. I'm going to do a switch. So I'm going to say switch current level case. If it's 1, I'm going to generate level 1. Now, in an ideal world, you generate all this from data. Okay, but I'm just doing it as an example. Right, so level 1 doesn't exist, so we're going to generate that. And this is just going to be the brick layouts for level 1. And I'm just going to do some rows. So I'm going to do a row of bricks and I'll do so many columns of it. Now we can do this by creating what we call a nested for loop. So I'm going to say for and I'm going to use tab tab to generate the number of rows. So I'm going to say rows. And how many rows shall I have? I'm going to have 5 rows. Now inside the loop, what I'm going to do, for every row, I'm going to generate 10 columns. So I'm going to say for column, and then columns, I might call it, like I did the other one. See how it changes that for us. Let's have 10 columns. And while we're generating this, we need to create bricks, which doesn't exist yet. So again, I'm going to say sprite. I mean, that's going to be a sprite as well. So I'm going to say sprite s equals new brick. And I want the brick to be created at a particular row and a particular columns. In fact, that rows and columns is enough name now. I'm going to change those in a minute. Right, it doesn't know what a sprite is because this hasn't got any of the using statements. So I'm going to go to any other one's ball or something and I'm going to copy all the using statements, overwrite the one that's there. So just paste them in. Now it knows what a sprite is. It doesn't know what a brick is though, so I'm going to actually say control dot and say generate a class for brick. Okay, and it's created the sprite. Now, while I'm here, I've still got it in the copy in the clipboard, so I'm going to paste the using statements. That was quite a neat trick. Now it's got in int rows, int columns, so it's worked that out, and it's said, oh, I'm going to save them for you, but we don't actually need to save any of these. So we're just going to delete them. Now, a brick is a sprite, so we're going to say gm.enginemanager.add sprite, this. We want a frame for it, so again, what we're going to do is we're going to make a rectangle out of the single pixel, so we'll do what we did for the paddle. Basically, it's the same sort of sprite, really. So we're going to say frame, define, text, single white pixel, and then we're going to stretch it. So we need to decide how big a brick's going to be. So let's say SX, so the width 40, SY, and I'm going to make them 15 high. We'll have to play back with those. I've now got to set the position. Now I can use the row number and the column number. So I'm going to rename these row and column, the two parameters. We can use those to set the position. So we can set the position. So the X position, the column. So these column numbers are going to go 0 to 9. So if we want a margin, so we can say always be from 200, and then we can add on the column number and then multiply that by the spacing that we want. Now we've made them 40 wide with the SX equals 40, so I'm going to make them 60 wide, 60 apart. We can do the same for the Y, so we say, right, start at, and I'm going to start them at 150, and then I'm going to say, whatever row you're on, so the first row will be at 150, the next row, when it's row 1, will be whatever this number is added on. So they were 15 apart, so I'm going to put that as 35. It might look awful. Oh, I've put rows, not row. Right, so let's just go back to the level generator. So it's running, it's doing a loop which starts with row equals 0, and then every time we do a row, we're going to do 10 columns. Okay, so we'll have row 0, so we'll generate a brick for row 0, column 0, and then 0, 1, 0, 2, 0, 3, 0, 3, all the way up to 0, 9. Then this loop will end, this column loop will end, and we'll start a new row loop, so that'll be row 1, and then it'll start this for loop from the beginning again, so it'll just generate row by row. Okay, let's run that and see what happens. It might look rubbish, but they're right over on the left. We haven't done collision detection yet, so we'll worry about that in a sec. I quite like the margin on the left and the height down from the bottom. So what I'm going to do is I'm just going to add more columns. I probably can get away with another 6 columns. So I just stopped it and I'm just going to say, well, let's do 16 columns. And this is the beauty of loops. So all I've done is changed one number and I get more bricks. Yeah, that's not bad. Let's knock it down. Let's do 15. Okay, so let's go back to brick and let's build collision detection in. So we make the collision active equals true. So that's the constructor for brick. Now, what we probably want to do, if a brick gets hit, we probably want it to be destroyed. So what we can do is we can create a funeral callback. So say plus equals, and I'll call it I died. I dead, can't spell. I died. So I'm going to say control dot and create that. So what happens, I can kill a sprite. So when the ball hits it, and we'll set that up in a sec, we will kill the sprite. What will happen is if there's a funeral callback defined, that subroutine will run and we can do things like score points and things. Okay, but what we'll do is we won't do anything at the minute. Okay, but we've got that ready and set up. Right, go back to the ball. In order for this to work, we need to create a collision handler. Now we want the game engine to actually do the bouncing for us. So we need a special type of collision handler called an epilogue. And it's an epilogue callback, so we can say so if we do callback, I can never remember what this was. Epilogue callback. So plus equals, we need to give it a name. So let's call it collide. That's not good. Let's call it hit something, because there may be other things in this game. So do control dot to generate that, and you can see it's created a parameter. And what happens? So when the ball, in this case, hits something, the sprite it hit is passed to this subroutine, so we can examine it and find out what it is. Now, I don't want to destroy the paddle when the ball hits it. I just want that to bounce normal. So I need to check to see if what I've hit is a brick. So I can do that with an if. So I can say if hit is, and this is how you check if something's a different type of object. And you can see actually it's had a guess as to what that might be. So we can say if hit is brick, then what we want to do is kill the one that we hit. So we hit dot kill, we say, and that will instigate that funeral, but it will also remove it from the game as well. Okay, let's see what we've got going there. So you see it's bounced off that, and the other thing we've got, I've done it again. I've left the rectangle for the brick as a um, circle. So I'm getting circular based angles, which actually I quite like because it makes it a bit different. So it's changing the angle the ball's in. I actually quite like that. And it doesn't matter with a game like this how accurate it really is. But let's change it back to a rectangle. So let's go to brick and change the shape. So shape equals shape dot rectangle. Just so we get it actually bouncing in a normal way. The last thing I want to do in this video, and effectively it's a finished game then, is I want to generate a score. So in game setup, okay, this is where we ought to record the score. I'm going to create, just inside the class, I'm going to create a score holder. Okay, so I'll default that to not, but I'm actually going to do that here as well, because a score equals not, so it's reset. And what I want to happen is every time a brick dies, I want the score to go up. Okay, we'll finish this game off in a second video, but I just want to get this bit working. Now we can do this. The game doesn't know anything. The game setup class doesn't know anything about the bricks. And you can see there's no reference to it. So what we're going to do is we're going to get the brick to communicate that it's died. Okay, so we can do that by using messages. So if we look at, I think it's in setup and loading and storage. I think it's in here. Yeah, we got this extra message types. And you see, I've already made some, but you can create your own. So I'm just going to copy and paste one of these lines, and just paste it at the top. And I'm going to put a comment in. I'm going to say brick gone, send points in message. Okay, just saying where it's going to be good. So I can't leave it as bullet destroyed. It's going to be brick destroyed. And the thing in the brackets over here is some debug output, so we can see what messages are active and subscribed to and things like that. So I've created a message. Now, the brick, when it dies, it needs to transmit that message. So what we're going to do is we're going to say message bus.instance, which is how you get used into the message system. And we're going to say, right, broadcast. Tell everyone I've died. Okay, so extra message types dot bricked destroyed, and we're going to give it some points. So I'm just going to say 10 points. Now what that allows us to do is you could have different bricks with different values based on their row or their column number or something like that. Okay, so we could do that if we wanted to, but I'm just gonna leave it as 10. Now, the nice thing about broadcasting is the brick doesn't know who wants this information. It's up to the people that want the brick death information to subscribe to the messages of type brick destroyed. So we're going to do that in game setup. So at the end of the constructor, we're going to say message bus dot instance dot subscribe, and we want to subscribe to brick destroyed. Notice I'm using the picker, and whenever this happens, these messages are broadcast, we want to run, I'm going to call it adjust score. So we're going to run a subroutine called adjust score, which doesn't exist yet. So we're going to say control dot generate method. So I just pressed enter to pick that first one. And all this has got to actually do is take the data in the message. Okay, so we're going to say score plus equals. Now, the data in the message is in something called object value. We've only got a single number here, so object value is that number, but you can have more complicated data transmitted. You can transmit a sprite if you wanted to. Okay, but we just want a number. Now, the object value is of type object, and we get you can't add integer and object. No, we know we can't. So what we can do is we're going to cast. So we've seen that before, casting, and that will do the score. Now, there's no point in adding up the score if we're not going to display it. So if we look at this logic code at the bottom, you can see there's already some display code that's showing the high score, which is already built into this template. So we're going to use the text manager. So we're going to say gm.textmanager.draw. This is how we draw text. It has to be drawn at every frame. There are 3 different versions of this. We're going to use this short one where it wants a font first. So we're going to give it a font from the font bank. Now I'm going to use Imagic. Obviously, you should keep them consistent. If I just press escape a minute, I've used Gradius font, which is from a Konami game series, but I'm using Imagic instead. Now, it now wants to know what text, so I'm going to say 1 up, then I'm going to put a tilde, and in my engine, a tilde causes a line break. I press the insert key, I think. Okay, so after that, I'm going to concatenate with the score. So what it'll do is it'll put 1 up on the screen, and underneath it'll have the score. Now I've got to set the positions, and I'm just going to do a basic one. So I'm going to say 20 pixels from the left of the screen, and let's do it 50 pixels down. Okay, so that's the most basic way of drawing some text on the screen. So I just pick a font, what I want to display, and the position, and that is the top left hand corner of the text. So you'll see that running in a sec. Okay, so it's a bit chunky there. So you see his score's gone up. Oh, missed. Meant to bounce that back. The ball's bouncing as if it's hitting a rectangle now, which is nice. And the score's going up. Okay, that's it for this video. So in another video, we'll make it a little bit more interesting, have different colors, and do some animation when the bricks get destroyed. Maybe shrink them or something, or make them drop off the screen. Okay, that's it.